Today I'm going to discuss statistical quality control. Okay. Uh, the objectives under this concept are identification and description of causes of variation, use of three sigma ellipses, use of control charts, difference between X bar, R, P, and C chart. Now, in SQC, there are three categories. Descriptive statistics involves the inspecting, measuring, and charting the output from process. They include the mean, standard deviation, and the range, which helps in identifying the process variations. Now, the second one is statistical process control that involves inspecting a random sample output from a process and deciding whether the process in producing products fall within preset specifications, which helps to catch in-process problems. The third one is acceptance sampling plans. The process of randomly inspecting a sample of goods and deciding whether to accept or reject the entire lot, which does not help to catch in-process problems. Now, the source of variations. Generally, variations are of two types. One is random variations. So these variations cannot identify, unavoidable, and cannot create. For example, floods. Okay, floods, earthquakes, all are random variations. Assignable variations. These are the variations identified, eliminated, and measured, whatnot. For example, employee training, faculty equipment, and defective raw materials, etc. Okay, now what is meant by quality? So, quality means in general mental satisfaction, but technically we are saying producers view quality as a set of standards and specifications. So, that is the a technical definition of a quality. But coming to in general what is meant by quality, so we can say very simple, so it is a mental satisfaction. Now, what are the types of controls we are in? There are two types of controls in quality control. One is process control and another one is a product control. In any production process, controlling and maintaining a satisfactory quality level of the manufactured product so that it conforms to specified quality standards called process control. Controlling the quality of the product by critical examination at strategic points, that one is called as a product control. So the while the process is going on, we are examining the quality of the item called product control. Okay. Now, in controlling of process control, we are using control charts, and these control charts are developed by Shewhart. Okay. In general, any control chart consisting of three horizontal lines. The one blue line is called as a control line, upper control line, and a lower control line. Okay. So any quality of a product beyond certain limits, so then the producers will become a loss. So the quality of a product will be decided up to a certain level, and the quality of a product cannot fall below certain limit. Suppose if it falls, the consumers faces a loss or a risk. So we have to put two standards, one for producers and another one for consumers, and these two are balanced by one control line. So any control chart consisting of these three lines. Now, any control chart constructed by control constructed by three sigma limits, and the three sigma limits will be calculated as a probability of t minus mu suffix t. T minus t, here t is a character, so a specification value minus its mean value will be less than 3 into standard deviation value, will be equal to 0.9973. That is 3 sigma limits. Suppose in the place of 3 we are using 1.96, then it will become 95% limits. Okay. Suppose 1.64 you are using 90% limits. So in place of 3 we are using 2.58, then it becomes a 90%, 99% limits. So on simplification of the term P of modulus t minus mu t less than 3 sigma t equal to 0.9973 will be simplified. We are getting the limits as mu plus or minus 3 into standard error of t. So here t is the character. Its mean called mu suffix t, and its standard deviation is called as sigma suffix t. Generally, control charts are classified into two types. One is for variables and another one is attributes. So, because general the quantities are classified into two categories. One is measurable characters and another one is non-measurable characters. So, the measurable characters are tested for quality purpose. We are using for control charts for variables. So, in this one we are using mean and range or mean and standard deviation charts. So, in variable charts, in attribute charts, we are using either P, fraction defective chart, or number of defects D, or number of defects per unit, that is a C chart. So, control chart for fraction defective, control chart for number of defectives, control chart for number of defects per unit. Okay, now coming to mean and range chart, that is those two are called as variable charts. Okay, now coming to mean chart. So the sample mean is calculated by x bar, or each sample calculated by x bar. Okay, the overall mean, that means suppose we are taking 100 samples. So then this overall mean will be x1 bar plus x2 bar so on plus x bar suffix 100 by 100. So that will give the overall mean. And the range is defined as a well known definition, maximum value minus minimum value. Its mean value is R1, R2, so on, Rn by n. R1 means range of the first sample, R2 means the range of the second sample. So, such a we are taking, suppose we are taking 100 samples, then R1 to R100 by 100. Okay. Now, once we are getting X bar and R, then we are calculating the 3 sigma limits. So, what are the 3 sigma limits? Mu plus or minus 3 sigma suffix t. Okay. So, for R chart, the 3 sigma limits for mean chart are mu plus or minus a sigma. Here a means 3 by root n. When limits are known, when limits are known, we are using mu and sigma values. And here the a value is calculated from the statistical tables. Now, generally, mean values mu and sigma is unknown. So we are using their unbiased estimates. So x double bar is the unbiased estimate of mu, and sigma, unbiased estimate of sigma is 3 by d2 n bar root n into r bar. So we are substituting those values, we are getting x double bar plus or minus a to r bar. Similarly, r chart limits, that is a range chart limits d2 sigma and d1 sigma. Here also sigma is unknown, so we are using their unbiased estimates, and then it becomes the 3 sigma limits for R chart as D4 R bar and D3 R bar. All the values A2, D1, D2, D3, D4 all are taken from the statistical tables. simple example. So we are taking a 10 samples. So each sample consisting of 5 observations. So I calculated. I am not giving you entire 50 observations because each sample 5 and I am taking 10 samples. So overall 50 observations. So, but I am not providing here 50 samples, but I am taking only their means and range values. The first sample mean is 43 and range is 5, like that. Okay. Now we are I am calculating the x double bar. That means 43 plus 49 plus 37 plus 45 so on up to 47 by 10. I am getting the overall mean x double bar. So 5 plus 6 plus 5 7. We are adding all the range values and by divide by 10 and we are getting the R bar. Okay, I am using x x double bar plus R bar and values. I am taking the A2 from statistical tables. So from statistical tables, I am getting the A2 value. So then the three limits for mean chart are UCL, LCL, and CL. Similarly, for range chart also I am getting UCL, LCL, and CL. Okay. Now observe maximum UCL is 47.54, but two values, that is the second sample mean and seventh sample mean, are beyond the upper control limit, and LCL is 40.854. 40.854. But the third sample and sixth sample mean values below the LCL. That means two values are above the upper control limit and two values below the control limit, lower control limit. But coming to R chart, all values are within the limits. So UCL is 12, but no range value is beyond 8. So all values below UCL. So only mean chart exhibiting two values above the UCL and two values below the LCL. Okay, so we are coming by observing those values, those observations, we are concluding the presence of assignable causes of variation should be traced. So assignable causes are existing on the sample, so thus it may be corrected. From range chart, none of the sample range values lies beyond the control limits. Now, control limits for attribute charts. Already we discussed. We are using three types of charts for attributes. One is fraction, another is the number of defects, and the third one is number of defects per unit. But here we have to discuss one more point here. So we are taking the uh, fixed sample size. There are variable sample sizes also there. Okay. Now, fraction defective chart. So that is called as a P chart. Okay. So the limits for fraction defective chart. So if D is the number of defects in a sample of size n, then the sample proportion P is D by n, follows a binomial distribution, and its mean value is capital P and variance is PQ by n. Okay. Now, in further session, I will discuss in detail about these attribute charts.